Programming Throwdown, episode 171, Compilers and Interpreters. Take it away, Jason.
Hey, everybody. This is super exciting. We got this request from a listener. Maybe later on the show, I'll find out, remind myself who it was. But, they said, how about you folks do compilers and interpreters? I can't believe we haven't done this episode. It seems so pivotal to everything we do in software engineering. But yeah, here we are to lead the way. I have to confess, I don't know as much about compilers and interpreters as Patrick, so Patrick's really going to carry the water here, but I will add color commentary as appropriate. And before we get into that, I wanted to talk about monitor setups for a little bit. So I was working next to somebody who had 3 monitors, like side by side by side, and they had 3 different things going on. Like they had one was for coding, the other one was for email. And I thought this was really compelling. I thought, oh, this is a great idea. And I just can't get myself to do it. Basically, I just have to have just one thing in front of me and just keep alt tabbing to go to different things. I haven't figured out how to, drag from one desk screen to the other and do all of that. What is your setup? Do you have, like an array of monitors or what do you do?
Yeah, 8. No,
seriously?
I do all my programming in VR, so I just have,
That's
I have as many as I actually do look for it. I think that'll be cool one day. That day is not today. I just have one big one, but I also have an iPad off to the side that I use for my conferencing, for video conferencing. That works well for me. So I guess it's technically 2, but one big one for sort of similar reasons to what you're saying. Like normally if you have 2 monitors, you just get them extra wide or on top of each other, which is too much, versus one big monitor. I feel you don't end up with that awkward split in the middle or have to shift one far to the side.
Right.
I will say for people who do like simulation race games or flight games, having 3 for a gaming setup would be really cool because you're one thing over 3. And the people who do, of course, the stock trading, where they're actually just it's mostly focused on one task, right? Like all of it is related. There's just lots of dials and metrics. It's akin to, I think, like a cockpit in an airplane where there's many indicators. Some are lower priority, but they're kind of very related to a singular task. To me, it seems a little bit different. Like when you're doing your programming, email is maybe that's not fair. I don't really know. I've never been those other things, but it feels like a different task. Slack or email, they feel different to the task of coding. And so, I'm with you. Like I don't feel compelled to have them up on the side.
Yeah, I used to do. I used to have my laptop. So like my laptop right now is just mirroring the screen of the main display. I used to have it kind of like what you're saying, where it was sort of a secondary screen, but I found myself not paying attention in meetings, even when I should be. And then I kind of couldn't do that. I guess, well, I mean, isn't this like a trope that people can't actually multitask?
We just sequentially singular task. Yeah.
Yeah, I mean, I just, but yeah, I mean, I do envy the people who can have like 3 different screens on and not be distracted.
I will say, I do find it's not all bad. I think if you occasionally need like a paper or a document, or you're implementing an algorithm and you want to consult something, or the few times I've had I'm generating some kind of output or whatever that's visual, it's very cool to have extra real estate where when I update something and click, test, I can sort of still see the code, but see the results and, up inside it. Screen real estate can be very, very useful. So I'll never sort of say something bad against someone who wants to have more screens, but the variety is, it is very interesting.
Yeah. I wonder, now that I'm working from home, it's less of an issue. But when I was going into the office, I was running into problems where, my home monitor and my office monitor aren't the same. And so, it wouldn't quite extend the desktop the right way and things would get all messed up.
That's the thing I've been picky about is I have my monitor pretty high. I'm fairly tall, so I want my monitor nice and high. So I either put little plastic risers or put it on a monitor arm and lift it up. So I have it higher than I think what I see a lot of other people do, just because it feels unnatural to me.
All right, we have to have a bake off here. My monitor is on I'm trying to eyeball it. Maybe like an 8-inch riser. What about you?
Oh, I'm trying from the bottom of my screen. I'm like at like a foot. Like, yeah.
Oh wow. Okay, that's even bigger. I might be a little bit more than 8 inches, but yeah, that is pretty tall. So like when you look at your monitor at eye level, are you looking at the center of it?
I wish it's not quite that high. The monitor I'm going to go quite that high. So it's I'm looking at like just above, something like 60% up from the bottom.
Yeah. Okay. Makes sense. Yeah. I'm about maybe like 75 or so up from the bottom. But yeah, if I didn't have any riser, the monitor, like my eye level would be above the top of the monitor. It's just unusable.
But I see people do that all the time. I can't.
Yeah. It's like, I think your neck would get hurt. I think if you keep it like that.
What I want to try is one of the very wide curved monitors. I think that would be really cool.
Yeah, I've tried it. I have one at work, and it's pretty good. It's pretty good. I will say that the one I have, the refresh rate isn't as good. It's not like a deal breaker or anything, but you do like if you have one monitor that has twice the refresh rate of the other, it can kind of like
sure.
It's like when you're at the store and all the differences between the TVs are so noticeable, but you take it home and you totally lose your frame of reference, right?
So if you have like a 4:3 aspect ratio or whatever, like not a 1080p widescreen 16:9, but like if it's curved left and right, does it also curve up and down if you get a nice tall one? Like, or I don't, is like on a sphere? I've never looked it up. I guess I should.
The one I have, I'm looking at it right now. It's curved, but just it's just curved like a cylinder.
It's curved like a cylinder. Okay.
Yeah, but it's very wide and not very tall. So the aspect ratio is not. It's not HD aspect ratio. It's much wider.
Oh, okay. Yeah, I think I would want one that. Yeah, I think I just want like a very large, like probably 8K, but like big. But then I wouldn't actually run it. Everything would be scaled up just so it's a comfortable eyesight thing. I think 8K would be too small at like minimum resolution or whatever.
Yeah, right. But yeah, folks out there, let us know your monitor setup. I'm curious. I do feel like I could do better. Curious to know what people's setups are out there. Just chat us, email us, post in Discord. Discord is getting more popular, so people posting some funny jokes. There was this video of this professor pranking his class, which I thought was hilarious. So thanks for
Wait, what? A professor ranked to their class? Okay, I had to go on Discord.
But pranking their class.
Oh, yeah. Pranking. I just said ranking. I was like, yes, we all know that they do that, but they're not supposed to actually do it.
RateMyStudents.com, new website.
All right. Well, we'll jump over to the news of the show. Starting off, since last time I mentioned this, and then Jason was excited about it as well. So I figure we'll talk about it here. The headlines, everyone's probably seen them, but I feel like it's pretty cool for something that is a memorable part of my childhood, which is being absolutely crushed and being terrible at the game of Tetris. But now there has been someone who has beaten Tetris. Actually, as of recording this show, I think 2 people have done it. So the world record didn't last very long after lasting for years and years. But BlueScuti, I think the first name is Willis, beat Tetris first, not at the earliest possible time, which was accomplished now, but did beat it. And here, actually, the reason why I think it's worth mentioning on the show, aside from just being a cool thing, and I linked the video there that is the first place I saw it. But it's interesting how they define beat here. So when Tetris was originally built, they didn't actually have an end game in mind, which is kind of unusual. It would just play faster and faster, and I guess the assumption was just it would play so fast you couldn't possibly keep going, and so eventually it would die.
A lot of games actually of that era are like that. Like Donkey Kong, actually, in Donkey Kong, the amount of time you have to finish the level goes down every time you have completed a full revolution of all the levels. And basically you get to a point where there just literally isn't enough time to finish the first level, like even if you're frame perfect, and that's just how it ends.
So Tetris, I guess, gets faster and faster, and then at some point it basically kind of caps out. Like it just doesn't go any faster. And for a long time, people would get to that area, that speed, and then just sort of die pretty quickly. If their row count was low, they would be able to manage to maybe get a few more lines cleared and then die. But then recently, people discovered a new way of pounding, tapping the controller faster and faster with this crazy two-handed technique, and they've been able to go faster and faster, and began to discover, which I guess people had figured out via tool-assisted speed running. So they had kind of known this would happen, but humans began to be able to get there, which is levels where incrementing the color palette left the predefined color palette and would start using actually machine instructions as the color selection, which would result in just really ill-formed colors that made it even more difficult. But then eventually a portion of memory would be accessed that would just cause basically a corruption of the data. And so when that happens, the game just crashes and stops and just hangs. And so this is what BlueScuti managed to do, was to basically cause the game to try to execute code that wasn't code, and then hung the game. And so first person to do that, it's crazy. It's very fascinating. It's also, and it's the same, as Jason was mentioning, sort of frame perfect analysis for Super Mario Brothers is any sort of speedrunning game that is from around that era. The amount of analysis and reverse engineering that goes into it. And there are even patched versions of the game so that like it doesn't get weird and you can keep playing, or, just other things where people really, really understand the mechanisms that, take place at this end game. And the amount of analysis, I'm sure the programmers at the time had no idea that, for 30 years, 40 years, people would be sort of thinking about what that code that they wrote in the back of a cubicle, somewhere and turned out.
Yeah, it's totally wild, right? I think, that whole thing where they do this crazy. I mean, you really have to see it almost in slow motion this way with two hands. So the idea is every frame, in Tetris, there's no inertia or momentum or anything like that with the pieces. So every frame, if you could get like a press left and a stop pressing left in those two frames, then you could move it over one whole column. And so they do this weird thing where I guess they hit the joystick from the bottom. So in other words, like if you imagine like just pressing with your thumb on a button, like there's only so fast your thumb can press and release this button. But then I guess they're saying, well, part of that is just like the mechanics of your body. So what if like you had another thumb kind of on the bottom of the controller, and so one thumb is pressing and releasing, but then the other thumb is pressing the bottom into the first thumb, and like I guess by doing that you can get more presses than you could with just one thumb. It's totally crazy. You have to see it.
I mean, I guess Tetris lends itself to that because I don't know. We'd have to learn more, but I guess you only have to move either left or right, as long as if you don't overshoot, and you only have to rotate the piece 3 times in a direction, and then you would just be back. So you can only rotate it 90 degrees. So there's like a finite number of presses. If you knew exactly what you were doing, your path planning, you could be very minimal inputs.
Yep, totally. All right, on to PalWorld, accused of being an AI product. So PalWorld is wild. Patrick and I were talking about it before the show. It really is a great area, a great theme for a game. Basically, it's adult themed Well, not adult themed. That means something totally different.
Pokemon with guns.
It's Pokemon with guns, and they're. I think they're also just really aggressive. Looking, you could actually catch people in the Pokeballs and sell them it's basically a crazy, much more like Mad Max. It's Mad Max meets Pokemon. It's a great idea of a theme. This article is really interesting. Patrick actually found this. and it's claiming that a lot of the assets are AI generated, but they have no hard evidence. And so I guess, there's really like two things that I took away from this. One is that, the generative AI is really, here to stay. It's not going anywhere. I mean, the days of downloading like 30 gigabytes of MP3s when you buy a game, I feel like those days are very short lived. I think even if you did hire a voice actor, you'd almost certainly want to do some type of capture of their voice, and if nothing else, just to reduce the storage costs and generate their voice dynamically. So that's definitely here. And then the other thing is, it's amazing that they don't know, because I've seen a lot of papers and other reports where you can see how something is generated by an AI. But I guess they have a point that it's really hard to prove it. I think the examples I saw were interesting. Like, for example, if you see and this isn't a PalWorld thing, but if you see a picture of a face, and the earrings don't match, if it's a woman's face or a man's face, anyone's face, and the earrings, they're wearing earrings and they don't match, that's a sign that it's generative AI, because it's hard for the AI to get that symmetry right. But they haven't really found anything like this here, and it might be just that person is starting with an AI model and then just as inspiration, but then putting a human touch on it, and it makes it very hard to track.
So, okay, a couple of things. If you're going to commit a crime, put on mismatched earrings and like do all the tips that are generative. So if someone captures you on the camera, you could be like, "That's clearly not me," because it's like
that's clearly an AI.
So I sense a trend where people do this. Second, a hat tip here to Ace Rolla. Ace Rolla does a YouTube video on shaders, actually. Anyways, and on Twitter, X is where I sort of first saw this controversy rising up. But if you've never checked out him, check it out, Ace Rolla. And then I think Jason's right. Is like, first of all, does it matter? Like if it's generative AI or not? And the answer is maybe. And it's sort of, gets into one of those gray areas. If it's fun, it's fun. But at the same time, there are people trying to put work into the craft, right? It goes back to that debate, which, I don't think there is an singular answer to, but, the difference between IKEA furniture and, Anderson real wood, piece of furniture, they're both furniture. But, you could kind of talk at length about, various pros or cons of each. And so I think in the end, as I don't know that even they have to be forthright or honest about what they did. They just, probably shouldn't go around claiming that it's high art or, that they somehow, that there's, tons of people behind it, right? If you tried to say, hey, you should support this game because this took a lot of work and it didn't, then, there's like a sort of ethics problem. But as far as, as long as if I think right now they're not saying anything, they're just not talking. It's, been a kind of overnight sensation. Then I personally, it's kind of interesting, but I don't know that I have a specific problem with it.
Yeah, I think as a coder, it's hard to really relate, right? Like all of our code that we've done on open source, like in my case, like Eternal Terminal and MameHub and all these things, they're all public repos. And so, AI is scanning those and using them to build GitHub Copilot and all these things, right? So in a way, they're kind of like copying it from me, but it's okay because I copied it from Stack Overflow anyway. But artists don't feel the same way.
But if I'm not an artist, so I can't speak authoritatively, but it's very common when people are learning to take inspiration, to practice copying and to understand what it takes, to make the paintings. And it's it's not good to copy too much, but to be derivative. Or you can even see sort of the lineage of how artists build on other artists' concepts and extend them and sort of push them forward. And so there's this very fine line between ripping off, Pokemon characters. Although if you look other places like Digimon, there's a lot of, Digimon monsters that look very similar, and the same kind of brouhaha didn't get derailed. Well, maybe it did. I was probably too young to remember. But, I don't know. There's a lot of, in music, it's the same way, right? Everyone's sort of taking riffs and ideas and from each other. And it's, there's been court cases recently where I don't know the answer. It sure sounds really similar. But then again, it's a nice sounding thing. If you just sit there and play music until you find something nice, you may play something that someone else has already figured out before. So, yeah. I mean, this is maybe, I'm trying to think if there's other examples before I say this, but I don't really think so. I mean, let's say this is all AI generated. Somebody basically threw all the Pokemon characters of all time into some AI model, and now they're able to spit out more Pokemon characters. This is really the first time where we've seen like some huge commercial success come out of some generative AI thing. Like people are so worried about, fake things, like you're trying to impersonate a politician or something like that. But this is, not really that. I mean, in terms of like the incentive is not to impersonate Pokemon. The incentive is actually the opposite. It's to generate something that has plausible deniability that it came from Pokemon. I mean, yeah, how many go on the App Store? How many Flappy Bird but with a, trash can?
So true,
right? Like, but to Jason's point, those don't experience the sort of commercial success. The numbers I've seen are absolutely crazy for how many people have bought this game. I haven't bought it yet. I'm tempted because it actually does look hilarious. But
my neighbors are actually going to play it, so I'm feeling kind of compelled to buy it.
All right. Well, hard pivoting off of this one, I found a blog article here, which is something that's been a sort of, I don't even know how to call it, not a meme and like a picture with an image macro or whatever pasted over top of it, but just a sort of meme like going around, which is kind of absolutely silly ways to solve determining whether a number is even or odd. And so I linked the blog here. The title of the blog, it says the blog's name is Blabbin, but this is the only post I saw on this blog. So I think a new blog. But anyways, the link is will be in the show notes. But this person was saying they saw on TikTok someone get kind of ripped, which again, I'm not on TikTok, so I can't, this is third hand at this point, but getting ripped for saying that they determined if a number is even or odd by basically a bunch of if else statements. So if number is 1, odd. If number is 2, that's even. If number is 3, that's odd. Oh, I'm going to mess it up already. Most people would say, oh, you just use a modulus operator if you know what a modulus operator is, or you use, bitwise and with the, first least significant bit just being 1, and then that'll tell you. Right? There's like a number of ways to kind of do this check. And most people would be expected as like a test of your language knowledge to know what the modulus operator is at minimum, or bit masking, depending on the context. But this person decided to take it on themselves to, for a 32-bit number, which is 4 billion different numbers, write if statements. And the interesting part, and the reason why I bring it up, is first just the absurdity of it. They decided to write it in C with what I sort of sounds like some tongue-in-cheek justification initially. But what they did, which is an actual interesting thing to learn to do, and, on topic a bit for us today, is to do code generation. And so they, wrote a simple program, far simpler than a 4 billion line program, to generate all of the if statements automatically. And that way they, could produce that output. And what does that take? Which is a useful skill to be able to know how to do, because there are times when doing not that, but other code generation, writing code to make code is very useful. That didn't work. The compiler, C compiler, didn't like that many lines. So then it decided to output raw assembly, and actually did get it to work, and I guess said it was very performant. if you think about it, it's almost just a big lookup table, and you can there are jump tables, so you can just basically jump to a set offset. So if you know each if else statement is 2 bytes and you had a very clever assembler or whatever, you could just jump, based on the number, that many, memory offsets times 2 or whatever. So I could imagine it being very, very efficient. And then just having a table where it either outputs 0 or 1. But yeah, so they actually did manage to make assembly that they say works. Of course, it's I guess we can figure out 4 gigabyte file roughly. So it's not gigantic executable.
40 gigabyte.
Ridiculous in that, like, this is, of course, I don't want to say this is a very silly way to solve whether a number is even or odd. But actually leads to some kind of interesting computer science exercises in doing this. And then, of course, people responded, can you do it for 64-bit numbers? And the answer is no.
Yeah. I love how this is the only post in this person's blog.
That's okay. You got to post something up when you have a cool idea and you want to show people. Like, I don't fault them.
No, yeah, no. I mean, I didn't mean that sarcastically. I literally love that this person. It's not like 10 posts about like hire me or like self-aggrandizing or any of that. It's just literally like, here's this cool thing that I did. Boom, blog.
I will say though, that's like a tough act to follow. So I don't know what you make post number 2.
That's true. Yeah, I mean, you really can't.
Just start a new blog.
It's been a month now, and he hasn't made a post. That is awesome. All right, my next news is Seamless M4T. Have you seen this, Patrick?
No,
This thing is freaking wild. So this is what I use to translate the episode. So if you haven't done this yet, go to programmingthrowdown.com. Depending on a bunch of factors, the very latest episode might not have this, but just go back an episode and you can listen to us in Mandarin Chinese. So it's totally freaking wild. So basically the way this works is it does the speech to text. Now, like, you have to have a separate file for each person. You have to have a way of separating, or in our case, we have a separate MP3 for each person on the show. But it converts that to text, and then it translates the text to other languages, and then it goes from that language's text to one of several voices that they have for each language. And so the reason why they're calling it seamless is I don't think that it's end-to-end learned, but it might be. But it is separate sort of modules. But the API and all of that is extremely simple. I mean, you basically just say, here's audio, and I want to get back text, or I want to get back text and audio in another language. I tried at first translating English to English. So it went from us to robot us. That was really entertaining. And then I started picking other languages. So this is amazing. I mean, it's amazing that it's free. It's totally open source. Anyone can use it. I actually bought for Black Friday a few months ago a GPU at 16 gigs of VRAM. That's the bare minimum you need to run this model. But if you don't have that, that's totally fine. I also got this to run on Google Cloud Platform, and you pay about 50 cents an hour, I think, to rent one of those. Yeah, very reasonable. You can even now, they have something where if it's idle for so many hours, it shuts itself off. So you don't have to worry about forgetting about it and getting a $500 bill or something at the end of the month. So yeah, all of that is super convenient. So you can run it on Google Cloud. There's also Google Colab. You can run it there. There's some 16 gig VRAM GPUs there. I don't know if the free plan would work, but the paid plan is only $10 a month. So yeah, check this out. I mean, it's amazing. I will say that there's 2 modes. There's a batch mode and a streaming mode. The batch mode loads everything into memory. So, you can really only use it for like a 10-second file or something like that. The streaming mode is really where it's at. The documentation is still pretty nascent. What I found really useful was they gave a tutorial at NeurIPS, which is a AI conference. They did a whole tutorial on Seamless M4T, and you can watch the video and follow along as if you were at the conference for free. I was able to find that. So check it out. Check out the tutorial. I feel like this is really on the vanguard of something super exciting. I'm looking into, can we clone our voices? Because if it could be Mandarin Chinese, but it sounds like us, that would be even better.
It's like a football earrings match. It's going to be like the deep fake Jason, but yeah, speaking Mandarin.
Yeah. So if in a few months you might hear Patrick and I in Mandarin, maybe we'll swap out an episode just for fun and see if people notice.
I hope people notice.
No, an old episode.
Oh, I see. People focus like the machine learning stuff on the OpenAI, and I understand why. And the sort of approach to AGI, I guess, like general intelligence. But you're right. There's a lot of stuff happening like out in the, call it, periphery, that feels like we're really moving forward, especially once we start combining some of these things. So there's been a long work separating back speakers. People say they can't tell the difference between us. So I don't know. Maybe that'll have to be like Gen 2 of that. But, having a single file, separating it back, and then, running it through the system and combining it. But also, I don't know that we've talked about it, but the sort of nerfs and Gaussian splatting around like making 3D models from, pictures. And right now they need kind of a lot of pictures of a specific kind, but, that'll get progress as well. And then you can imagine the sort of stable diffusion feeding into those things. Like there's like a lot of interesting sort of like 1-2 iteration away. And probably requiring some leaps there because it's not sort of like gluing normal software together. But there's a lot of exciting stuff happening that I think gets missed for the focus on LLMs.
Yeah, I actually am more excited about diffusion models than LLMs. We should do a whole show on diffusion models.
All right. Well, we know a person who could probably speak to that. It's not me.
Oh,
I'm saying you.
Yeah, I was wondering if we knew a third person. But yeah, have you seen the diffusion model with Bomberman?
No.
Yeah, so basically, okay, let me just do a really quick, and then we'll dedicate a show to this. The way diffusion models work is you have a bunch of references. So in the case of Mario or Bomberman or any of these games, you have levels that were created by humans, right? That's your reference. And you want to create more of those, right? So what you do is you corrupt the references. In this case, the Bomberman levels. You corrupt them, but the way you corrupt them is reversible. So whatever you do, the exact way to undo it. And then you train a model to reverse the corruption. All right. And then once you have that model trained, you give that model like random noise, like levels that are complete garbage, and you just tell it to reverse the corruption, and you tell it to do it again and again and again, and you tell it to reverse the corruption until it gets stuck in a cycle. When it gets stuck in a cycle, you say it's done, and that's your Bomberman level.
It should have guarantees on like playability, like not having like something you can't reach or.
So it doesn't, it's all just AI. So there's no guarantees of anything. You'd have to do some fine tuning afterwards. Okay. But it's like scarily like true to form,
yeah.
I can't remember if they I can't remember if they wrote something to throw out the levels, like they wrote basically a validator and threw out all the bad levels, or if they just they didn't actually make a real game with it. It was a research paper. So they might have not bothered to do that. But you see the levels and it's like, Yeah, that looks pretty cool. Like I could see how that could be kind of a fun Bomberman level.
Well, you should save it for the diffusion, but I guess like there's like some randomness that goes into how you select each operation. So I guess almost like backtracking, you could just naively get towards the end and sort of try to go back and assign some attempts or whatever, and this do a validation at the end. Like, did I get a good level? Did I get a validatable level?
Yep. Yeah, exactly.
Oh man, it's going to be cool. The future is scary. We're all going to be out of jobs.
The future is super scary. I mean, I definitely wouldn't want to be in the games industry. I mean, as an engineer, you would be fine. But if you're a concept artist or, a voice actor or something like that, I mean, it's going to be
there are some heads of studios and stuff coming out and basically forecasting like reduced need for a lot of those things. People talking about, for doing like cold calling and sales calls and informational sessions, maybe reduce need for folks there. And then, also some places are getting flooded. There's always been a sort of like low bar Kindle book, ebook, coloring book, drawing, just like, low effort sort of written word kind of stuff. And all of that too, I think is this AI stuff is sort of competing with not the top tier stuff, but the sort of like low tier, low effort people churning those out, hoping one or two people buy them or whatever, which has proven successful. I think there's a threat to those. Not that that's going to be a big problem, but once they start targeting people who are higher up the food chain there, that's going to be a struggle. And I will weirdly segue that into our book of the show from high quality books that are definitely not AI generated.
That's right.
So my first one, I might have recommended it before. If I did, well, it's worth a second recommendation. I tried looking, but after 171 shows, it's a bit of a process to try to search for it. And that is Foundation by Isaac Asimov, which is a actually many book series. And the first one is, great place to start. And recently this became a TV show, which I think renewed some interest. The TV show doesn't follow the book super closely. But if you've never read some of the classic science fiction, it's really like a fascinating trip to see how close some of the stuff got from people writing long before, computers were a thing, much less mobile phones. Some stuff is just like laughably wrong. And some stuff is just like, wow, that's eerily the same issues we're dealing with today. And so reading classic science fiction is something worth doing if you've never tried it before. And the Foundation series is I feel like a pretty formative series of science fiction. And just to give people a flavor, since I've not said anything actually about the book, is the idea is there's an empire ruling the galaxy, and there's concern that these people raise that the empire is going to collapse, and it's going to cause humanity basically to be set back and really be a struggle, and everyone's going to be bad off. And so they've created a sort of way to help shortcut that to make it better. But of course, the empire itself is very unhappy with this. And the whole prediction that this was going to happen is this, of course, fake, but it sounds very convincing, psychohistory, which is this idea that you cannot predict individuals, but that, sort of like I think the analogy they use is like a gas. You can predict a lot of statistics about gases, even though an individual molecule in a gas is very, very difficult to predict. And so through that, they can kind of predict the course of human history and how things will go, and make updates and help keep it on, a plan that will sort of benefit the most humans. And it's just a very interesting read in the dynamics. And so if you've never read it before, and if that sounds at all interesting, although I probably did a poor pitch of it, or if you've watched the TV show and maybe didn't realize it was also a book, I'll pitch Foundation by Isaac Asimov.
Yeah. Did you read it recently, or is that when you read it?
I read it actually as a teenager. So I read it a long time ago.
Yeah, same here. I have to confess, I don't remember that much of it, but I do remember having a big impression on me when I read it.
I think I also had kind of forgotten I read it. And then I looked up the sort of summary and I was like, oh, I remember. And then I actually have watched, I think there's a couple seasons now of the TV show. And I will say, it's a pretty dark thing. So not watch with kids, but pursuing the same kinds of ideas. And I thought I like it, even though it doesn't follow the book that closely. It uses some of the concepts and the sort of setup to kind of examine some of different ideas, but in a similar vein.
Cool. Yeah, definitely. If folks haven't read that, definitely give it a read. It's a great series. My book of the show is Propaganda by Edward Bernays. So this is a fascinating book. It's so wild that I almost, I wouldn't take it all as ground truth, really. I mean, a book about propaganda might be propaganda. It's kind of like meta, but but basically the premise, which they get right into in the book, is that and again, this is not my theory on life, but that basically, democracy can't work. And so you really need to have just like a few different ideas to follow, that it can't just be a total free for all. I mean, a good example is the app store that Patrick was talking about, where there's like a million knockoffs. Like you could search pretty much any word in the dictionary and you're going to find a video game based on that word. And they're all kind of cookie cutter, and it's very hard to get noticed in the app store or to find good content. And so you're really relying on the, editor's picks. And so in a way, it's like you have this really democratic platform, but what it really degenerates to is just like a handful of editors' picks and folks who have a big audience already and all of that. And so the claim by the book, by the propaganda book, is that, there's just so much content, and this was written 100 years ago.
1928.
Yeah, there's so many clubs that you could be a part of. There's just so many choices, so many brands, so many this, so many that. That really propaganda is the way by which like 90% of your options get filtered out, and you can just focus on the top 10%. So it almost becomes like a way to ante in. It's like, okay, you have to build this propaganda machine to be part of this system, and everyone who doesn't do that ends up just getting kind of lost, right? And it dives into how propaganda works as a bunch of examples. Some of them were pretty mind blowing. I won't spoil them, but maybe I'll spoil one. There's this cigarette company that they were under a lot of pressure. There were a lot of moms who didn't want their sons and daughters smoking because they had heard about all these issues. I don't know if lung cancer was a really known entity in the 1920s, but they thought there were health issues, and so they were able to like start up this like women's liberation march sponsored by Marlboro, and they basically tapped into the women's liberation movement of the 1920s as sort of like a back pressure, against like this, like kind of like Mothers Against Smoking group, and the whole thing is just blowing my mind. I mean, it goes without saying that I think it's fair to say Patrick and I are like, what would you say? It's like task oriented in the sense like we're definitely not master manipulators. We're not like these kind of people. Patrick doesn't even have a social media account. Oops. I barely use my social media account. And so for me, this is like a whole different dimension to, humanity, really. I mean, it's something that I never would have really considered or thought of if I hadn't been recommended this book. So I found it absolutely fascinating. Highly recommend it. Very interesting read.
Yeah, I think sometimes words get like artificially intense negative things. So I think like some of these things yours was saying. The other one I'll kind of by analogy or by similarity talk about is politics. So like people talk about, I don't want politics in the office. It's like well, you need to be aware, regardless of whether you want to quote unquote play politics. Politics is a like human way of, that things happen and decisions get made, and backroom decisions, these kinds of, you have to be aware of them if you want to kind of like at least have some modicum of control over what happens. And I think by extension, propaganda is similar. It's it has a very, very negative tone to it, but it's a way of lots of people doing stuff. They may not see it as propaganda, right? They just see it as, hey, I'm trying to get my ideas across or find a way to make people more open to this. But sort of calling it out and putting a label on it and saying how common it is a way of sort of engaging with it.
Yeah, and it turns out actually the negative connotation to the word propaganda is also propaganda. So the word, they actually talk about this. The root of the word propaganda comes from the Catholic Church in like the 1600s had a part of seminary where they were kind of teaching priests and bishops and cardinals about how to kind of spread Catholicism. And I think that's where the word actually comes from. And then, and then I think, and so at that time it had a positive connotation. And I think the connotation flipped over time as a society. We got kind of like, not happy with like proselytizing, and then now it's like really like commercial propaganda and all of that. So yeah, like the propaganda, I think, collided headfirst into the Enlightenment and lost when it comes to reputation as a word. But yeah, but the book is totally mind blowing. Highly recommend people read it. And to Patrick's point, and we talked about this in the marketing episode. We had an episode with a gentleman from marketing. Like you have to, I'll give you a really concrete example. I made that game AI Hero, right? I made it totally free. There's no ads, there's no in-app purchases or anything like that. I told my friends and family about it and all of that. And it has, I didn't check recently, but it has, I think like 100 downloads or something like that. And now, I made it, to be frank, I kind of made it for myself. So I'm not out there trying to get a bunch of downloads, but I was even still surprised that it got such little notice. And it really just doubles down on that point that, you have to get a propaganda cycle going, a marketing cycle going for anything that you want to have mass appeal. Otherwise, there's just too much content out there. So yeah, it's not a propaganda marketing. These aren't words that you should be afraid of. I'll say that it's not something that, at least I don't know about Patrick, but it's not something that I personally am very good at. It's definitely something where I try to partner with other people who are much better at it than I am. But it's something that, I think we all should really appreciate. It is very important. If I did want AI Hero to get, a ton of people, I would have to go about things very differently. I think, I'd have to be posting regularly on Reddit. I'd have to figure out some way to maybe gin up some controversy. Maybe I would make a fake post saying that it's generative AI, pretending to be somebody else attacking me for using generative AI. I don't know, but this is just from reading the book. There's a million things you could do to amp up your thing, whatever it is. But if you don't do that, probably no one's going to pay attention. And that's true in politics. If you make a political party, nobody's really going to care. It's true in most things. So yeah, it's just a fact of life.
Yeah, I think there's a lot to say here, but probably just move on for now so we could
all right, yeah,
keep moving forward. So time for tool of the show.
All right, what's your tool?
Not a tool, a game. But nice. Classic Patrick cop-out. Mine is, I've been getting into these recently, but this is the one that I sort of encountered first, which is The Room. This is pretty old at this point, so most people have probably played it before. If not, I would encourage you to check one of them out. Often they're very cheap or free on sort of Android, iOS. I think there's a Steam version, probably a web version somewhere. But the idea is basically kind of like an escape room in an app. Just like without the time limit, you just like a series of puzzles, and you interact with them. And for me, I've actually never done an escape room. I want to. I just like it just hasn't been a thing that I've been able to do. But I'm sort of fascinated by the concept, and these games are just like an easy way to spend a few minutes sort of playing with something and trying to figure it out. I will say in the genre, some games do it better or worse, and I have my own particular sort of like, I don't like things that you're just supposed to try random stuff until they happen. There should be some clue that you can look for, and it can be obscure, or it could be that you have to pay attention or whatever. But sometimes it fall into like, how was I supposed to know that? Like, there's no indication that you're supposed to, touch the top of the windowsill and like it's going to be movable. It's like, okay, but so sometimes you fall into this. But anyways, I guess a pitch for these kinds of puzzle escape room games in general, and there's many in the genre, but for me, the first one that I sort of bumped into was the Room series. I think there's like now 4 or 5 in the series, but shout out to the original one. And if you've never played one before, check it out.
Yeah, totally. I've played The Room. I think it's great. A lot of fun. It taps into your common sense. So yeah, you do have some intuition into what the answer to the puzzle is. My tool of the show is also somewhat of a cop-out because we've had them on the show before. We did, in fact, had a whole episode dedicated to Incredibuild. But I was building a new version of MameHub on my house today, I guess, because it's like using all the desktops in the house, which is kind of the point of the tool. And I just thought to myself, man, this is such an amazing tool. I've used it for so many years for free. If you're using it for your home use, if it's not for professional use, it's totally free. That I felt like they deserve another shout out after so many years. We've gotten tons of emails from folks who have got their company to buy Incredibuild and all of that. So we have been able to drive some business to them, which I'm really proud of. But yeah, it's Incredibuild. If it basically, the way it works is it hooks into your build system. It even has plugins for Visual Studio. So if you're building on Visual Studio, it works. If not, it has, it hooks into GCC and all that stuff. And you just, instead of, choosing build solution from Visual Studio, you choose, start Incredibuild. And I have the Incredibuild agent running on all the desktops here in the house, and the fans all start whirring, and they all start working together to build stuff. So MameHub takes, I think, like 2.5 hours to build. But with Incredibuild, I can get it done in like 10 minutes or something. So it's super nice, and highly recommend it.
Very nice. Very nice. All right. Well, I think it's time for our topic, which is compilers and interpreters.
Yeah, this was a request by Jessica W. I won't say your last name. I know some people might be sensitive to that, but thank you so much, Jessica, for this idea. It's a great one.
All right. I didn't know, Jason sort of bowed out of like, well, that's not my background. So it kind of fell to me. And I struggled a bit with the tack to take here because there's a lot to be said. This is a big, request. So I decided to take a stab at what I'll say is a sampler, kind of going through a bunch of different topics in the area with some sort of high level overview. But, choosing a interpreted versus compiled language, I guess you could say choosing a compiler versus interpreter. But most of the time, if you choose a language and the pros and cons of the language, you're sort of choosing one of these for that. But then in each of these, there's just an incredible depth you can go into or not. Most of the time, I guess, we're big believers in the right tool for the job. So despite the fact that I may throw stones at Python, a lot of times you're only going to run an analysis once, or, it doesn't really matter how long it takes. And so you can get this just really big worry about speed or performance or, selecting exactly the best tool. But I will say most of the programs I write are probably run less than a dozen times ever. Even to check them in and put them in at work, and I may run it a few times. Someone else may use it. We may copy and paste the code around, but any given instance is just not that. And then a very few are, run hundreds of times every day and, or thousands of times, inner loops and calls and those ones. And so there's a really wide range. And so find a few things that you're sort of proficient in. And I'll say, way of disclaimer before we dive in here, is just sort of like, you'll see a lot of internet flame wars about, that's slow because it's scripting, or, if you're going to build something in Godot, don't use, is it GD script, because it's going to be slow. And if you're finding yourself in a problem and maybe you want to listen to some of that, or being aware is good. But I feel a lot of people hesitate to take the first step and get what, I'll call analysis paralysis, from making a decision. And actually, better to just build something and let it suck and be slow and introspect why at the end of getting somewhere with it, and then make a follow-up choice, than to never take the first step.
Yep, totally agree.
There's a balance there, but okay, off of my soapbox. All right, so I guess anytime we run a program, we're talking about a processor, and we were talking in the Christmas episode, holiday episode. Jason was mentioning, now I already forgot if it was RISC-V or RISC-V. I think
RISC-V. Yeah, we found it.
Yeah, okay, good. RISC-V, and RISC-V is a instruction set architecture, a sort of way of having computers run, and it has, I guess, what you would call machine code. So out of wherever it's loading the program, probably RAM, and then it sort of loads a set of bits, right? If it's a 64-bit processor, it loads 64 bits and can kind of look through there. And part of that is the operation to perform, and some instructions about to load it from a register or to load it from a place in memory or whatever. And then the processor sort of handles that. And that is machine code. If you ever do like NAND to Tetris, or there's another game where you build logic gates out of NAND on your web browser, or you take a class in university where they're sort of teaching you about sort of building up from like VHDL, how to kind of like, implement a processor. You'll end up realizing it really is just, hex numbers on a screen that you end up getting executed in there. That's your program. And every kind of family of processors has a different set of instructions, a different way of organizing those operations. And to write a program in it, you would have to sit there and really write, a hex. Well, you could write binary too, but most people would write it in hex, and that's the way we sort of think about it, because it gives you the nice byte delineation. And you would not do that after about maybe one time of doing that. You would not want to do that anymore. And so, as an example, like when we did Motorola 68K processors, which is just, one of these families, when I was in university, and we had to do this as a task, like, write some, machine code. And I did that once before sort of realizing, wait a minute, I'm just going to write a program to be like a crappy assembler, and, do that. And so then that moves us to assembly language. And so assembly language is just like a very light skin over this machine code. So you're pretty much have a one-to-one correspondence, but you're writing English symbols. So instead of hex code 47 being the move operator, where you move, one set of bytes to another location, you would say MOV, move, right? That's a lot easier. And then the registers each have names rather than just numbers, like, R8 or whatever for register 8. And so this is the first time we encounter what you would call a compiler. And the compiler takes those English letters, or whatever language you're writing in letters, and maps them directly and emits the bytecode.
So does that mean that it's reversible? Like, can you go from machine code to assembly code?
Yes, great question. So you can, and it's called disassembly. And for assembly, and I'll talk about a caveat here in a second, it's pretty straightforward. So if you take a program that lives and you haven't gone, we had, that was many years ago, but we had the folks from, I think, Intel in here talking about obfuscating your program codes, that people can't do that. And they can't sort of like patch it or do what would in video games would be a hacking, or, in more critical software trying to get your keys or something. But yeah, so you can do disassembly. So you can take the bytes flowing through your processor and sort of convert them back to assembly, because it's a very direct mapping.
Got it. Okay.
So the caveat there that I was already alluding to, and you can help here, it's not too bad in assembly, is what I've described so far, you kind of do in a single pass. But that also turns out to be easier to do better than, and it's frustrating, so you wouldn't want to stay there very long, which is you may want to have an example where you have a loop. And so when you're on a loop, you want to go back in your program to somewhere previous, or skip forward if you have an if statement. And if you were doing what I described initially, and that's kind of like a single pass compiler, you would have to calculate, go down, figure it out. It's 8 instructions for my loop. So I need to go back to that branch statement and say, jump 8 instructions down. And that'd be really annoying. So what people do is implement the ability to add labels. So you can put a label, end of loop. And you can say, jump, JMP, and then you can put end of loop. The issue is when you're doing a single pass compiler, you're scanning down and it says jump, end of loop, but it's never seen the symbol end of loop. So it doesn't know where to jump to, right? And so now you get what we call sort of a 2-pass compiler. So now you start to get what you would kind of think about, like variable names and labels and jump statements. It's not really that much extra, but your productivity goes way higher. And for many years, people coded in assembly with 2-pass compilers. And the 2-pass just means first scans through to find all of the symbols that are names and their locations, and then on the second pass does the actual emit the machine code, and now it knows, this offset is this many instructions down, and it's able to produce the machine code. But that
does it literally do it in 2 passes? Because I could also imagine, like, anytime you see a jump forward, you just keep track of it, and then you go back and fill it in.
I mean, but that's still, you can't do it in a single. It's not 1 pass. Because you have to go back up, right? And emit. Right. So it's like the big O notation kind of thing. Like, how do you want to call it? I'm sure they get pretty sophisticated. There's probably, it's just calling out that the progression, I guess, in here. But still, these assembly languages you're writing in, there's kind of some asterisk here. But for the most part, you're writing it per kind of processor. So if you want to write it on if you're going to use an Arduino, which is, I think, based on a PIC chip, then you need to use the PIC flavor of assembly. If you want to do this in, Motorola 68K, x86 processor, ARM processor, if you're, going to run on a phone, every one of these has a different set of instructions and therefore a different assembly language. And so again, that gets really crappy if you want to ever write for more than one thing. Or you want to go faster, because you're pretty much still basically writing 1 line of code per instruction, which is going to make you very easily able to sort of intuit about sort of like runtime and complexity of things a little easier than a high level language. But again, it gets kind of frustrating. And there are concepts for still everything that's in a high level language sort of has to be capable of being done in assembly language. So you still see things like doing function calls, so jumping to a function and pushing stuff onto the stack. For some processors, those things are strictly implemented by a higher language compiler, but some processors actually have support for that, even at the assembly language level. And you would sort of start to call those things complex instruction sets, CISC, versus RISC, reduced instruction set computers. And so there's a whole separate topic. We'll sort of leave this here because we'll go forever and move up the family tree, I guess, to higher level languages.
Yeah, that makes sense. So every programming language like that you read about, like C, C++, Java, Python, they're all considered high level.
Yeah, right? Yeah. I mean, there's degrees to that, I guess, but at least when I sort of started learning about this, and they shift over time, right? There was early on, it was you writing in assembly, or you were writing in, something that wasn't assembly, and anything that wasn't assembly was, high level. And the idea there being, in my mind, at least, the delineation, and it maybe it's moved over time, but if you write a line of code and it produces sort of an arbitrary number of machine instructions, then you're now writing in a high level language.
Got it. Okay.
So in a line of C code, just as an example, or Java or whatever, you can write, A plus B divided by C times D, to the power 2, whatever, right? That's one line, but it's many, 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 assembly operations to do that, depending on architecture. And the compiler now is able to target different backends. So if you write, and we'll talk about sort of C, C++ here for a second. If you're writing in C or C++, you can compile against many different processors. So you could write one program that runs on ARM or on x86, because the compiler is picking up your code and we won't go into bit, but building, sort of finding the symbols, building a syntax tree, and it knows how to emit the proper machine code for, executing that program. And it can do that with many passes, depending on the compilers, but many compilers also emit a sort of intermediate representation. So even different front ends. So you could say like an LLVM, you'll see things that can target, the LLVM IR intermediate representation, which is something between the sort of machine code assembly and the high level language that lots and lots of front ends can compile into. And then there's a specific set of operations and libraries and team working on taking that intermediate representation and compiling it down to your specific final machine. And so then that's called the back end. So you have the front end compiling it to intermediate representation, and then the back end taking it from intermediate representation to a specific class of processor.
Got it. I see. So if you wanted to write a new language, you could create a language that compiles to the LLVM immediate representation, and then you'd be guaranteed that it would run on all these different processors.
And not only that, you're also going to benefit from a bunch of optimizations that the sort of like imagine loop unrolling. So you write a loop in this intermediate representation, and now the sophisticated folks across all these languages, economies of scale kind of thing, can implement loop unrolling or some stuff we're going to talk about later, but can implement it at the IR level, and then you can benefit from it.
Got it. Cool. That makes sense.
So now you mentioned Java as well. Java gets a special shout out here, which is that when Java is compiled, and this starts to say, these are words we use, but there's no requirement that it has to map cleanly. So Java also targets sort of an intermediate representation called the JVM, the Java Virtual Machine bytecode. And so it does get compiled, and it has all this, optimization and stuff that can happen. And then it produces basically a machine code. But the machine it targets is the Java virtual machine, not an individual processor. And when it was first developed, this was a huge boon, because now you talk about portability, you can run on anything that there was a JVM for. And LLVM wasn't really a big time. So, again, times change. But at the time, this was like seen as like a really big thing. And Sun Microsystems at the time, were sort of pushing that, hey, Java really, runs on, I forget, they had an ad, some obscene number of devices and, has this ability. And so there, you're compiling it down. And then the Java virtual machine has an implementation per, kind of architecture. So it has an ARM implementation, and it has an x86 implementation. And the implementation of that virtual machine is to take that bytecode and pretend it emulates this sort of conceptual computer that is like almost like a lowest common denominator. But on some processors, it may be able to be very efficient with a certain operation, and others not. But you don't have to worry about that, because it's sort of just handled for you. And all of the standard libraries can have sort of special treatment or efficiencies added. And so this was a very interesting approach, but it sort of threads the line here where you have, it's not a scripting language. We'll talk about that in a second, but it's not a true compiler in that there's still an emulator, a virtual machine, as it were, that sits in the middle here. And sort of that's the program that's actually running. So that program is running your program. And so the compiler is not targeting a machine. The compiler is targeting, it is targeting a machine, but it's not targeting a physical machine.
So if I understand correctly, right? So the difference is with LLVM, you're going to this immediate representation, but then you're instantly going to machine code. And so now you have machine code that can only run on that architecture. But with Java, you're still going to this intermediate format, but you're not doing that second step to go to machine code at compile time. You're doing it at runtime.
Yeah. So the intermediate representation is not really executed, right? There's no program. Well, again, you could write one, but the intention isn't that there's a program that runs the intermediate representation. Versus in Java, there is a program, the JVM, that runs your JVM bytecode.
Got it.
Okay, so then now we get to sort of scripting and interpreters. The idea is sort of similar. It's very rhyming, which basic was this way, other things are this way, and that is rather than a compiler, you're running a program that needs to work per architecture, but that program is doing all of the work at runtime of executing your script. So it's converting the symbols you wrote into, or the letters you wrote into symbols. It's building whatever it needs to be able to execute it. So if you're, setting a variable name, like Jason was mentioning, it's keeping track of that, but it's doing it sort of fresh every run. And so it's opening it up. And if you have, as an example, a typo halfway down, you're going to find out about it down your program's execution or whatever. And so it's not attempting to, in the sort of level 0, it's not attempting to do anything other than just sort of execute your script, right? So if you've ever written Python and you have a typo at the bottom of your program and your whole program runs and then doesn't output the answer because it crashes at the end, this is happening. It's not trying to compile. It's not trying to look ahead. It's just there is the program that's running per architecture is parsing the script input at runtime.
Yeah, I mean, you can. This is starting to really boggle my mind now that I'm thinking about it. Like in Python, you can open the interactive interpreter, and you can actually you can write if statements and for loops and anything you can write in Python, you can write in there. And so you can actually write a for loop. In that for loop, have a break if a certain condition is met, and then keep going. And so Python has to kind of remember that you put that break there, but it doesn't really know what's going to happen after the break because you literally haven't written it yet. And so that's to kind of keep track of all of these things while it's interpreting what you're writing.
It's also not that it's impossible in other places, but it becomes much more straightforward to things like Python loves to do, which is modify definitions on the fly, right? So changing variable names to another type, or to even modifying functions that are on a class, because all those things are sort of held in memory, right? The sort of processing, the compilation goes into memory and is just held and is done sort of in real time, at execution. And so modifying that stuff is more obviously, straightforward to implement. More not obvious, but you can kind of envision how you would do that if it's a thing sitting in RAM versus if you've compiled it into something that you emitted to the disk, right? And you're sort of executing it out of read-only memory. And again, there's lots of things that blur these lines, but yeah. So scripting, when people sort of think about it, it can be slower because at runtime you have to do more, right? You have to convert the mapping. You don't need to know that your variable name is some complex, set of underscores. When you're doing the compile, you just map it to, this is the first variable I've seen. So it's variable lookup table entry 0, right? And it's literally just a pointer or just an index 0. And then every time you see that, you're keeping track of it. But in the final program, it all gets taken away, right? Because it's just everything points to the right spot and all those things are resolved. When you're doing scripting, though, when you're marching down the program, that table has to live in memory and you have to go do that lookup, right? Oh, Jason's most complicated, very long named, but not meaningful variable, that has to get parsed, which is a lot of characters, and has to get that mapping to take place every time it's seen sort of at runtime. And so this gets to why people kind of say scripting would be slower. But as Jason mentioned, the advantage is because execution is happening at kind of while you're doing it, and all these steps you can also modify the steps, and it becomes very easy to do and to interactive and to kind of see what's happening, and very straightforward.
Yeah, that makes sense. I believe if you your machine code is loaded into the process memory that you can't touch. If you start writing in the chunk of memory where your machine code went, it'll they'll assume that you're trying to do something nefarious or something or a mistake. But in Python, there's probably no way to catch that.
A lot of early viruses did this self-modifying code. So they, people screen them, they look normal, but then they get modified to do something that is nefarious, at execution. Yeah, a lot of systems will try to stop or prevent that and assume that you were making a mistake and at best preventing you from doing something you really weren't supposed to do.
Yep, that makes sense.
But yeah, that's it. Yeah, that's mind bendy stuff when you start talking about that. Okay, couple other things I wanted to cover briefly. You'll hear about. So one is JIT, which is just in time. So for scripting languages, all is not lost about these runtimes. So in Python, as an example, or other things, you can have a JIT, which says, hey, I've noticed that this piece of script has been executed. This function has been called many, many, many times. So I'm going to, rather than every time I get to it, do all the parsing and all the work again, it can effectively do a compilation step, right? It can go ahead and resolve all of those things. It could do, implementing them all the way out to machine code or the operations or whatever, right? Java has this as well for bytecode, but basically at runtime, sort of observing that you're about to do something or that you've done it before and pre-computing and storing those results so that the next time you do it, you get your execution. That's sort of the concept. I'm probably doing a bad job, but of just in time, right? It's just in the nick of time. I've provided you a optimized thing to run.
Right. And you could do the loop unrolling and all of that stuff. Like if you know that this for loop's only going to execute it 4 times, or you don't know it, but you're confident, then you could unroll it.
Yep. And you could even do code analysis to do it, right? Again, extend these all have like research directions or implementations in various features. And then the last thing I want to talk about that also blurs the line, though, is something that's actually really interesting. I've never seen it, which is profile guided optimization. So some of these drag races, I guess you call them, between sort of scripting languages and compiled languages will show, hey, actually, this Python code is a lot faster because in this case, during runtime, Python, the interpreter observed these behaviors and performed this optimization that you couldn't have known a priori. It had to be known sort of like at runtime, and it gains this advantage. It's true. That can happen. That is a thing. And it can be really cool. In compiled languages, we're starting to see some work around profile guided optimization, which is run your program and you record a bunch of statistics about how many times various loops. By default, was this if statement skipped 99% of the time? And even compilers do some of this. Even processors do some of this to help with optimization, but sort of recording statistics about what was executed, how much, and various sort of things. And that the sort of call it happy path, you make a guess. I'm just going to assume this is going to be true, and I'll add a little check. If it's true, I'm going to gain this boost. And if it's not true, then I'll have to execute something a little slower, right? No free lunch. But it does this via a profiling. So you've profiled your code, and now this optimization uses that profile of the code as a sort of almost second compilation. So you run the compilation, you insert all these sort of like, extra hooks to measure stuff. You look at the output, and then you run compiling again that uses that as input, and it's able to sort of be more thoughtful about how to perform certain optimization steps of compiling.
Cool. So if people are really excited about compilers and interpreters and they want to work on the Python VM or the C++ like GCC or something, where does most of that work take place? My guess is probably like government programs and giant companies and stuff. But like what would be your career advice for them?
So there are folks working at, big tech companies that you sort of hear, right? If we sort of name some, Dart, at Google, or Swift at Apple, or I think Java is still at Oracle. Obviously those places have teams that work on these things, and you can go work on them. But I think a lot of it also happens as hobbyists do stuff, in university. This is compilers and interpreters is a course you can take. If you want to do it as a job, what I don't know is like how you, as a job, without working at a big company that has a vested interest in it, you sort of get paid to make a very cool LLVM and intermediate representation optimization. Definitely something you can do. And if you have a company that will sponsor that work, which is, maybe a hard thing to find, I don't know that it's not like writing a game where you just do it and then people pay you for good output. It'd be very difficult to write like a new language that someone would pay you just to like consult on. My opinion, maybe I'm wrong.
Yeah, I think you're right. I think even if you set out to, create a new language, I think even then I would probably start by working for one of these big companies. I think I want to say one of the military labs is like the chief person on GCC, like Sandia or one of these labs. I don't remember, but basically, for all of these things, LLVM, Swift, GCC, look at who their biggest sponsors are, right? Look at who the domain name of the email addresses that are most prevalent on the mailing list, right? It's not hard to figure out who is actually putting in most of the effort for that particular compiler or interpreter. And then once you know that, then it's a matter of creating changes, basically doing that job kind of pro bono for a little while and proving yourself to those folks, becoming ingratiated by those folks, and then reaching out to them and saying, hey, I want to do this full time. And so if that's something that interests you, that's the path for it to do that. You don't need to be a master propagandist or anything like that. It's a very simple formula. Just put some sweat equity into that. Talk to the folks who are also putting in that sweat equity, and that's how you can do it.
I'll give two shout outs quickly. I don't think this is the first thing you do, right? Write programs for a while before attempting to write your own programming language.
Right.
Probably a good move. But two resources that I think are really useful here. Many more, but people would have recommended the Dragon compiler book before, but I never made it through it. Anyways, the first one is by, and I might not say the last name correctly, but Robert Nystrom, and he wrote game design patterns, like design patterns for games. That's very useful. Definitely check that out. I think you can read it free online, but also read free online Crafting Interpreters. So craftinginterpreters.com. And I think there's a web version, but I think there's actually now a physical book as well. And I haven't sort of gone through it and implemented it myself. It's on my to-do list, but definitely a way of talking about how would you add an interpreter, implement polymorphism, how would you handle variables, and sort of building up your own programming language, and sort of not going to be, I don't think, state of the art, pushing the envelope, but definitely giving you a flavor for this, which I think is really useful to know how some of this stuff works. And then in the sort of opposite side of that, I mentioned it, but nandgame.com. There's also Nand to Tetris, but nandgame.com is really easy to jump in and start showing you starts one touch too low maybe for what we talked about today, where how do you build a NAND gate? How do you make an OR gate from a NAND gate? But quickly jumps in, basically, how do you build the actual processor components, the parts that do math? How do the bits get added, and why is it that a certain machine code byte evokes a certain behavior from the pieces of the computer, the actual silicon? Anyways, and so you can just play it in your web browser and just sort of go at it. You might have to Google some help. I did. Sorry, but how do you implement registers? How do address buses work? Anyway, so that's nandgame.com. We'll put them both in the show notes, but two sort of useful resources.
There's a modern take on this game too called Turing Complete.
Oh, I've seen this, but I didn't want to pitch it because I haven't tried it.
I haven't tried it either. So I haven't tried Nand to Tetris either, but it has amazing reviews. I just looked it up. It's overwhelmingly positive. Steam reviews, 2,200 reviews. So that is a really good endorsement by the community.
Yeah, I've heard a lot of people say it's another good resource, so I'll put it in the show notes too.
Cool. All right. Thank you, Patrick, for going into a ton of detail here. This is an awesome episode. Thank you, Jessica, for recommending the topic. Phenomenal topic. And thank you to all of our patrons who are kind of supporting the show, helping us reach new people. I was looking through my email the other day about something kind of unrelated, and I stumbled upon a email from a listener a while back who we were able to help them find their first job. I mean, that stuff's really inspiring. Continue to send that to us. We read all of them. Sometimes we read them twice. Sometimes we find them years later and read them again. So thank you, everybody out there, for listening, for supporting the show. and we will see you next time.
Music by Eric Barndollar.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.